Hello my dear students and welcome to today's class. As you can see on your screen, the topic is light. So in this chapter I am going to tell you about rectilinear propagation of light, reflection, refraction, dispersion and about human eye. So let's start the chapter. Children, right now you are able to see me. Why? Because I am standing under the light. Okay, in case the room is dark and I am standing, you won't be able to see me. Reason behind? Because there is no light. Okay, so what light is a medium which makes the things visible to us. Okay, so let's start the chapter now. How are things visible? As you can see on your screens also, how are the things visible? Children, the objects that emit their own light, okay, which gives out light, are known as luminous objects, whereas on the other hand, the objects which do not emit light or do not give on their own light is known as non-luminous object. If I talk about luminous objects, right now I am standing under the light, so tube light is there, that is a luminous object. Then sun is the main source, it gives a lot of light. Okay, so sun, tube light, candle, these are all luminous objects. The pen which I am holding in my hand, it's not emitting its own light. Okay, so it is a non-luminous. The book from which you are reading is also a non-luminous object because they are not emitting light. Okay, so fine, let's start the chapter now. Objects that emit light of their own are called luminous objects. Example are the sun, candle, bulb and tube light. And objects that do not produce light of their own are called non-luminous objects. Example are book, pen, shoes and bed. Okay, so we see luminous objects because the light that they emit enters our eye. Okay, the light falls on the retina of our eye. Light is there, it is falling on the retina. Our eyes is there, so eye has got a part, a retina. So the light falls on the retina of our eye and it is passed to the brain. The brain interprets this message and an image is formed. This is how we see luminous object. Okay, but we are able to see non-luminous object also. Like you have a book, you are able to see it. Why is it like that? Because the light is falling on it and the light which is falling on it is getting reflected back on your retina again. Now when it is falling back on your retina, what is happening? The brain is interrupting and an image is formed. Okay, so your room is very dark, you are searching for your book. You switch on a torch light and show it around the room. Now you can spot your book lying on the table. How did you see the book? Because of the light from the torch. The light that fell on the book from the torch was reflected by the book and enter your eye. Once the light enters the eye, similar process takes place and the image is formed. So non-luminous objects are visible only if they are reflected, if they reflect light and that falls on them from another source. Okay, now moving to the next page. Okay, rectilinear propagation of light. What does this mean? It means that the light always travel in a straight line. Okay, the phenomena of light traveling in a straight line while passing through a transparent medium or vacuum is called rectilinear propagation of light. Light always travel in a straight line. Okay, now how is shadow formed? How is shadow formed? ठीक है, कैसे होता है shadow? What is shadow? Shadow is परछाई. How is it formed? Okay, you observe how light travels in a straight line. Now holding the same position, ask your friend to stand between the wall and the torch light. In other words, you are asking your friend to stand in the path of the light, blocking it from falling on the wall. Observe carefully. What do you see? You will see a dark patch roughly in the shape of your friend formed on the wall. This dark patch is called a shadow. When any objects come in between the path of the light, a dark patch is formed. Okay, and it is always falling on the opposite side. Okay, the shadow is always formed on the opposite side of the light. Fine. Here, a shadow is always formed on the opposite side of the source of light. A shadow is dark in color irrespective of the color of the object that blocks the light. Now we'll talk about what is reflection. Okay, Now you know that light travels in a straight line. Let us take an example to explain reflection. What is reflection? Okay, suppose a ray of light falls on a surface. The moment it hits the surface and the same ray bounces from the surface, the phenomena in which the ray of light falling on the surface bounces back to the medium from where it is called reflection. Okay, reflection means bouncing back. Okay, light is falling on the object. Suppose the object, this is the object, light is falling on it, and what is happening? It is reflecting back. Okay, it is bouncing back. That is known as reflection of light. Okay, now moving to the next one. I'll tell you what an incident ray is, what is point of incidence, what is reflected ray, angle of incidence and angle of reflection. Okay, listen very carefully. I'm going to read out. Please listen. Okay, let us see how reflection takes place. Let us xy represent the surface of the plane mirror. This is the plane mirror. See, you can see this is the plane mirror, and x and y, they are representing the surface of the plane mirror. The ray of light that comes from an object falls on the surface of the plane mirror to be reflected is called the incident ray. Okay, you can see the plane mirror is there and the source of light is coming. This is incident ray, and the light which is reflected back, okay, that is bouncing back, this is called reflected ray. Okay, in the figure given below, the incident ray is indicated by AO. Okay, this is A and this is O. This is incident ray. Okay, then point of incidence, the point at which the incident ray falls on the plane mirror is called the point of incidence. Here the point is here, it is hitting the surface here, so that is known as point of incidence. Now what is reflected ray? We already know that when the incident ray AO hits the surface of the plane mirror, it gets reflected. Okay, it is getting back. This ray that bounces from the surface of the plane mirror is called reflected ray. Here the reflected ray is indicated by OB. You can see O is here and B is here. This is known as reflected ray. Okay, now we'll talk of angle of incidence. The angle between the incident ray and the normal is called the angle of incidence. In this figure, the angle of incidence is indicated by M or AON. Here, this is AONN. This is angle of incidence. Then angle of reflection is the angle between the reflected ray and the normal ray is called the angle of reflection. Here, the angle of reflection is denoted by BON. Fine, children? Now, laws of reflection. What laws are there? Okay. The first law of reflection states that the incident ray, the normal and the reflected ray meet at the point of incidence and lie in the same plane. Okay. An object A emits light that falls on the point of incidence on the surface of the plane mirror AO. The incident ray gets reflected and the image of the object A is seen at B, formed by the reflected ray BO. Here you can see better. Laws of reflection they have shown. The first law states that the incident ray, the normal ray and the reflected ray, they all lie on the same plane. Okay. Now the second, what does the second law state? The second law states that the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to angle of reflection. Fine, children. First stated that they all lie on the same plane. The second stated that the angle of incidence and angle of reflection, they both are equal. Fine. Now moving to the next one, image formed by plane mirrors. Here, the two laws of reflection are always followed when reflection of light takes place, irrespective of the type of mirror used. Okay, it can be any mirror, it can be a plane mirror, it can be a convex mirror, it can be a concave mirror. Okay. But the image formed varies in characteristic. We will learn about the image formed by the plane mirror in detail in this chapter now. Okay. Now moving to the next one. Here. Can you all see? First, the size of the image. First is the size of the image. Hold a book in your hand and an eraser in another. Now stand in front of the mirror. Look at yourself. Do you look bigger or smaller than you actually are? No, you are look at this. You are of the same size as you are. You always see yourself in the mirror. Okay, like right now I came from my house, I dressed myself and I had a look on the mirror. Did I found myself smaller or bigger? No, it was same. So whenever you look at yourself in a plane mirror, the size of the image is the same as the object is. Okay. Then upright image. When you look at the mirror, how do you see yourself? Do you see yourself upside down with your feet towards the ceiling? No. The way I am standing, I would be able to see myself the same in the mirror. The image won't change. Okay. It would not be like that. My head is down and my feet, they are up. No. Fine, children. Then the distance of the image formed. Stand in front of the mirror. Now come closer to the mirror such that your face is touching. Look at the image formed in the mirror. What does the image show? Does it show you still standing normally in front of the mirror? No. The image formed in the mirror is also too close, like the way you are. Suppose I am there, I am standing in front of the mirror. If I am going to be far, the image will also go far. In case I come closer to the mirror like this, the image which I am seeing in the mirror will also come close. Fine, children. Now lateral inversion. What is lateral inversion? Have you seen an ambulance on the road? How is the word ambulance written? It is difficult to read at first. But do you know why it is written in this manner? Okay, you must have seen ambulances on the road. You must have seen the word ambulance. First, it is somewhat you are not able to read. Why is it like that? So, you are in your car, an ambulance is behind your car. The image of the ambulance is formed on the rear view mirror of your car. In this image, the word ambulance appears to be of correct manner. It is easier to read. This phenomena in which the image formed of an object appears to have undergone left-right inversion is called lateral inversion. Why is it like that? Because in case the ambulance gets stuck in the traffic, we can see the image in the car mirror. So we would be able to read it very carefully and we would be giving the way to the ambulance to go. Fine. Now what all are the characteristics? First is the image is of the same size, as I told you. The image is upright, right now I told you. The image is at the same distance from the mirror as the object is from the surface of the mirror, and the image shows lateral inversion. Okay, so these were the characteristics of the image formed on a plane mirror. Okay, now types of reflection. The next topic is types of reflection. All surfaces reflect light, but the image formed by all reflecting surfaces are not the same. Some of the images formed are blurred or not clear, while some of the images are very clear. Some gets blur, okay, some are very clear. So it depends. Okay. Now moving to the next one. Yeah. If the reflecting surface is rough, it does not reflect light, but the beam of light reflected travels in all directions. Why? Because the surface was not smooth, it was all rough, it was all curved. So what is happening? When the light is getting reflected, it is going in all directions. So this is called diffused reflection. Okay. Hence the image formed is blurred and not clear. That is the reason why the image which is formed by that type of reflection is not very much clear. Fine. Now multiple reflections. Okay, what is multiple reflections now? We know that when we stand in front of the mirror, the number of images formed is 1. This is because the number of reflecting surface, that is the mirror, is also 1. Now what happens if you use 2 mirrors? Most of the shops where you buy clothes have mirrors on both the walls, such that you are standing between 2 mirrors. How many images do you think will be formed? Okay, you go for shopping, you go to saloons also for your hair cutting and all. Okay, once he uses 1 mirror. Once you got your hair cut and all, he uses 2 mirrors. Now one is in front of you and the other one is at the back of you. So how many images would you find that time? Many of you will think if 1 mirror forms 1 image, then 2 mirrors will form 2 images. No children, it is not like that. This is not true. Due to different angles in 2 mirrors, the number of images formed will be many. Okay. The 2 mirrors at an angle of 90 degree will show 3 images. For example, when you go to a haircut, just now as I told you, once you are done, the barber holds a mirror behind your head. When he does so, you are able to see the back side of your head in the mirror that is in front of you. The number of images formed in this case is 3. In case he is holding the mirror at a 90 degree, the images formed would be 3. But if he is not holding at 90 degree, the n number of images, means lot of images would be there. Fine. Now this is an activity you can just go through, okay, in which it is shown, see, to show the number of images formed in different angles. You are keeping the mirror in different angles and you would be finding the number of images keep on increasing or decreasing by the way you are placing the mirror. Okay, now moving to the next one. What is refraction now? Okay children, what is refraction? Let us understand one more phenomena of light. Take some water in a transparent glass, dip a long pencil in the water. Now observe the pencil from above. What do you see? It looks as though the pencil is bent. Why does the pencil appear so? This is because of the phenomena called refraction. The phenomena in which the direction of the path of the light changes when it passes from one medium to another is called refraction. In case you take a glass, okay, put a pencil in that, what will you find? You will find the image, when you see the pencil, you will find it is somewhat bent, okay, and it is somewhat thicker and thinner at the base, but the part which is in the water, it would be appearing as somewhat thicker, okay. Hence, the light is entering from air and passing into water. This change in medium from air to water causes the light to bend at a certain angle. Hence, the pencil appears to be bent. Fine. Now, what is dispersion? I hope refraction is clear to you. We will talk about dispersion now. Take a CD and observe it. You can see different colors on the CD. You take any old CD and you will see lot of colors on that. Why is it that? The CD does not have different colors, yet you are able to see them. Okay. Why? This is because when a ray of light passes in it, the light splits into component colors. The light that falls on the CD is called white color, and the light consists of 7 different colors. As you all know, VIBGYOR. You must have heard of this word. They are referred to as VIBGYOR. When the light falls on the CD surface, it splits into VIBGYOR. Hence, the different colors. White light is made up of 7 different colors: violet, indigo, blue, green, yellow, orange, and red. And if we term them all together, that is known as VIBGYOR. Okay. Now, moving to the next one. Here. The same principle is followed when white light falls on the prism. It splits into component colors and emits light of different colors. Okay. This phenomena in which white light splits into its component colors is called dispersion of light. When the light is falling on the prism, what happened? All the white light, it gets splitted into different 7 colors. Okay. The band of light produced by the splitting of white light is called a spectrum. Here you can see the light is passing through the glass prism, and here it is splitting. Okay. Now the next one. This is the way how you can make a kaleidoscope and a periscope. Just go through it, is very simple, nothing much to explain in this. Okay. Now, very important, human eye. What is human eye? We are able to see through our eyes only. In case I close my eyes, I will not be able to see. So, only the eye is helping me to see. So, let's start now. An eye is an organ that helps us to see the world around us. Let us learn more the human eye and its part. First, the following are the internal parts of an eye. First is pupil. The aperture at the center of the eye through which light enters is called the pupil. Okay, pupil, you have seen this eye is there, and this dark part you can see over here, this is called pupil. Through it only the light enters the eye. Okay, then comes the iris. It is the colored part of the eye and helps in controlling the amount of light that enters our eye. It's not like that the whole eye light would be entering. Some part of light only enters the eye, and whose duty is there? The amount of light which is required is done by iris. Okay. The iris controls the increase and decrease of the size of the pupil, thus controlling the amount of light entering it. Okay. Now moving to the next one. Lens. This is the part between the iris and the retina. It helps in focusing the light that falls on it to the retina behind it. The lens made adjustment by bending the path of light so that it can be focused on the retina. Okay. Now we'll talk about ciliary muscles. These are tissues that are attached to the iris on both sides of the eye. They control the focal length of the lens by making the lens thick and thick. Okay. Now we'll talk about the next one. Next is sclera. The white part of the eye that is filled with a watery fluid called the aqueous humor is called sclera. Okay. The white part, you can see the eyes is there. The white liquid part is known as sclera. Now cornea. Cornea is the thin transparent layer of tissue that covers the front of the eye. When we talk of donating eyes, it is the part that is being donated and not the entire eye. When you plan to donate your eyes, when you are no more in this world, so what part the doctor is going to take out? It is only the cornea, not the entire eye. Fine, children? Then retina. The eyeball on the black side has a thin lining that is sensitive to light. This lining is called the retina. Okay. Now optic nerve. Optic nerve connects the eye to the brain and helps in carrying the electrical impulses generated by the retina to the brain and the interrupted response from the brain to the eye. Fine. Now, okay. Blind spot. Have you ever heard of this word, blind spot? No? Chalo. Let's start. The optic nerve originates from the portion of the retina. This portion of retina does not have light receptors, that is cones and rods. Hence, the light that falls on the portion cannot produce any image. This portion is called blind spot. Fine. Now, power of accommodation. The next topic is power of accommodation. To start, our eye has a unique ability to observe the things distinctly anywhere from about 25 centimeter to infinity. Okay, you can see the things at infinity also without any problem. The ability of eye lens to adjust its focal length so that we can see the objects located anywhere is called the power of accommodation. The minimum distance at which things can be distant by a human eye is near point of human eye. For normal eye, it is 25 centimeter. Okay, if I put the things like this, I won't be able to read. Okay, I have to, when I want to read, I have to keep the book at a proper distance, and the minimum distance is 25 centimeter. In case I put the book like this, here very close to my eye, I won't be able to read. Okay, the farthest point at which a human eye can see is called the far point of human eye. For normal eye, the far eye point is infinity. Okay, now persistent of vision. Okay, the next topic is persistence of vision. So start. The impression of an image formed at retina does not vanish immediately. The impression persists by 1/16th of second in our brain. So if stationary means still images of a moving objects are flashed on the eye faster at the rate 16 images per second, our eye then perceives that object is moving. This is called persistence of vision. When we go to the movies, the motion pictures creates an illusion of a constantly lit screen by flashing individual photographs in rapid succession. Today's motion picture flash images on the screen at 24 frames per second. Televisions too uses this phenomena. Okay, why we are able to see the images moving? Due to the persistence of vision. Okay, so now our eyes, we are able to see with eyes. Then on seeing and seeing, with the age or some of the other problem, we get some of the other problem in the eye also. So what are the defects of the eye? Okay, what all defects we can have in the long run or maybe in a short run also? First is cataract. This is the defect of the eye in which the lens get affected. The lens become opaque or cloudy, due to which it is not able to focus the light on the retina. Hence, image appears blurred. Sometimes this is double vision or no vision at all. Cataract, you must have heard of this word motiabimb also. In this, what happens? A film is formed on the retina. Okay, it is formed on the lens of a eye and we are not able to see the things properly, or what happens? The image is somewhat blurred. Okay, and what is the remedy for that? Minor cases of cataract can be corrected by using spectacles or contact lens that helps the lens to focus light properly. Major cataract cases are treated with laser surgeries or surgical operations. In case, especially in the old age when the person get cataract, the doctor advises either to use specs or he or she can get it operated. Fine. Now second is myopia. Okay, myopia. Myopia or short sightedness is a defect in which the person suffering from it cannot see objects clearly that are far away. In this case, the image is formed in front of the retina. Okay, and what is the remedy? We go to the doctor and he gives us specs to wear. Okay, myopia is the short sightedness. Okay, we are not able to see the things which is at a short distance. Okay, sorry, the things which are at far distance. Fine. Now moving to the next one. Hypermetropia. Okay, hypermetropia or far sightedness is the defect in which the person suffering from it cannot see objects that are nearby. Although you are saying hypermetropia or far means dur. Okay, far sightedness, in which it is a disease in which the person is not able to see the things which are very close. Okay, so the lens cannot focus the light on the retina properly, hence the image is formed behind the retina. What is happening in hypermetropia? It is forming behind the retina, but in the other case, if I talk about myopia, in this case what is happening? The image is formed in front of the retina. Fine. Now with this I end the chapter. I hope you all have understood. Go through it once again so that your doubts are clear. Thank you and have a nice day.